Hi everybody, I'm Scott Callan. Thanks so much for joining today. As Kumi just pointed out, we're going to focus primarily on the strategic developments around Beyond Display. We made a number of announcements yesterday, and so this is in a sense kind of a way to explain kind of what we're up to. The most important announcement is that we decided to end production at our Mobara fab in March 2026, and we'll consolidate the production in Ishikawa. I'll touch on this later in the call, but the display industry is plagued by kind of asset-heavy, high-cost fabs with low profitability, and so it's critically important that we reduce our kind of the costs and the asset heaviness of the business. And the second element that is a challenge is that, and I'll explain this also later, is that the display business is plagued by chronic lack of profitability, and there's some structural drivers of that. And so it's very important we address both of those things, and we're doing that via our Beyond Display strategy. So the great thing about Ishikawa fab is it's going to be profitable. It has lower fixed costs and has G4.5 substrates, which are much better for semiconductors, sensors, and microdisplays, which are going to be key elements of our Beyond Display strategy. Mobara will be sold as an AI data center. It's right next to Tokyo, has over 100 megawatts of power. It's really, really well suited for it. We'll meet Mobara fab customer requirements by increasing production and transferring production to Ishikawa fab and our foundry partners. We will go fabless with eLeap, and quite possibly our FMM or conventional OLED business. We're focused here on eLeap because it is the future. It's extraordinary technology. We are building, for the first time, and we can build it, a foundry fabless model in the display business. You can only do that as a fabless provider if you have very strong IP, if you have capabilities that only are available to you, and we do. eLeap fits that. We're in multiple discussions with foundry partners. We expect to go global with eLeap in a fabless business model, which is really, really powerful. We announced yesterday a strategic investment and partnership with OLEDWorks, who is fantastic, super capable, US-based OLED specialist, best in the world in what they do with OLED multi-stacking. We're proud to go with them to build an advanced U.S. display fab that's going to serve the defense, automotive, and medical industries. More on that later in this presentation. On the semiconductor side, we announced two strategic alliances: one with Panel Semi in Taiwan, another one with Tech Extension to jointly develop and produce advanced semiconductor and sensor technology. Again, this is going to be at the Ishikawa Multi-fab, and we're calling it a multi-fab because this is also something that's very powerful. That fab is going to simultaneously be able to produce G4.5, G6 substrate displays, sensors, and advanced semiconductor packaging. It's going to have a broad set of capabilities. We will run out of capacity at it. One of the challenges we have right now is we try to keep both the Mobara fab and the Ishikawa fab running, therefore lowering utilization at Ishikawa, which had the lower cost structure. We're going to move everything to Ishikawa. We're going to load up, and we probably run out of capacity. And that will be a very good thing. It's going to be a profitable fab. I won't go through the financials that much because they're on track. Sales are down, OP and EBITDA is up. The only thing that we announced is that we're taking one-off costs on shutting down the Tottori and Mobara fabs, and that's really good for our shareholders and our going forward profitability. So let me jump to the strategy element of the presentation because that's really what's critical. This is what we're doing to become robustly profitable on a going forward basis, and it's Beyond Display. We have a set of corporate capabilities. Those are not being deployed in a way that's profitable for our shareholders or our stakeholders, and that needs to change. And again, the answer is Beyond Display. Let me touch on kind of the structural profitability issue. On the right-hand side, we call it mass market displays, which is probably not fair because we have very high technology capabilities, and so do a number of our peers. But the problem with kind of large screen displays is they operate on what we call the enlargement principle, is that customers prefer them to be bigger. And so you have a 5-inch display, people want it to be 6-inch, they want it to be 7-inch. If you have it's a 20-inch display, it's better than 25-inch because larger displays, in contexts that aren't micro displays. So let me be clear, we're distinguishing between big displays and smaller displays. But when things need to get bigger, you'll have a fixed kind of substrate. And every year, as displays get bigger, you get fewer displays out of your substrate. And so, and unit prices don't go up. You go to a 70-inch screen from a 6-inch screen, and the price should go up something like 14 to 15%. I'm doing the math in my head. Doesn't. And so economics worsen over time. That is the huge challenge of being in markets where there's an enlargement principle on the customer side where they prefer bigger. And what's so powerful about going to semiconductors and sensors and microdisplays, and by the way, OLED is fantastic in microdisplays, and it's a capability that we have, and we're deploying at Ishikawa, because as I said earlier, Ishikawa is better suited with the smaller substrates to serving these markets. The great thing about products that operate on the miniaturization principle is that, and semiconductor sensors and microdisplays are examples of that, and a microdisplay example would be things like AR and headsets, is that the smaller they are, the better they are. And so you're constantly making them smaller, year after year. And as a result, and unit sale prices don't deteriorate because as you're making them smaller, they're becoming more valuable. And so your economics improve over time. It is absolutely critical to understand that core driver of value. And people talk about what's so difficult about the global display market is almost everybody, including us, struggles with chronic poor profitability. And it's described as, well, one of the challenges is the Chinese government sees this as a strategic industry and has put in huge subsidies, and it's made it impossible for anyone to price to economic value because of strategic value that the Chinese have correctly seen in this. And that's true. But the Chinese have also seen strategic value at semiconductors and have thrown kind of equal amounts of money at that. And the semiconductor industry is profitable. And it's because of this key issue. Is getting smaller better for you, or getting bigger better for you as a customer? And the problem with big displays is that economics erode over time. This is why, when we say beyond display, we mean beyond mass market displays. We will have a bright future in semiconductor sensors and microdisplays. And it's rooted in the more powerful economics of these industries. As I said earlier, Ishikawa is becoming multi-fab. It's going to be super flexible. It's got world-leading tech. It's got 1/4 of the fixed costs of Mobara. It's a low cost. It will be able to do all of these. It's going to do G4.5. We have fully depreciated equipment that we're going to move from Mobara to Ishikawa. We'll be able to load the fab without additional costs, without additional people. Over time, we go really hard into semiconductor sensors and microdisplays. We do have an existing set of businesses that we can make profitable. They're not the big future for us in terms of being robustly profitable. We'll be able to move our display production there and make it profitable also. So what happens in Mobara? The big fab, it becomes a data center. It's got the building specs to meet data center requirements. It offers over 100 megawatts of power in a country where there's not a lot of power, and I'll touch on that. It will be robustly profitable and generate a lot of money for us and improve our financial position when we do that sale. In November, we indicated we were going to put up the V3 area. As you can see, this is the entire Mobara fab. It's V3, which is not producing, the J1 fab, which is currently producing. We're adding on to it the J1 fab, as I say, we're closing it, and so it has great facilities. Industrial water supply is becoming more important. We'll have to see where we take the technology globally in semiconductors, but water cooling has become far more important. We've got engineers, we got talent, and this will be a sale. But there is a shortage of talent. We have super skilled engineers. A number of the potential buyers are having conversations with us about whether we can support them in terms of our technical capabilities, and we can. So that's an important part of the package, potentially, depending on the buyer. This is we showed this in November. Japanese compute is going absolutely through the roof. 100,000x in compute demand in the 20 years between 2020 and 2040, and Japan cannot fill it. This is why taking a non-special purpose facility like our Mobara fab it's got great structural engineering. It's got HVAC. It's got cleanliness. It has a lot of the characteristics you want from data centers. That's why it works. But it's not a special purpose data center, and so it would be your second choice. But you don't have a second choice. There's a shortage of land. There's a shortage of power supply. There's a shortage of construction. And so if you want to do something in the near term, and we've had conversations with the EPCOs, the electric power companies, like we'd like more power, and they literally ask for, it's 2024, so this is the end of last year, can we get more power? And like, yes, we'd be happy to serve you. The year is 2044, 20 years from now. So this is a very powerful solution because data center demand is exploding. It's not just AI. It continues to build out year after year, and there's just a chronic shortage of labor that's linked to both the aging out of Japanese construction labor force, which is down 40% over the last couple of decades, and very, very strict rules on overtime that have been a kind of a double punch to the industry. It's very hard to get stuff built. And that's relative to not only construction and power supply. That's why you can't get grid hookups also. This is what the Mobara fab looks like. When we talked about in November, we discussed it having 44 megawatts because that was V3 only. As we add on J1, the other part of it, this is over 100 megawatts. It's extraordinarily attractive. It is the only 100 plus megawatt site in the Tokyo metro area. It's right next to the Trans-Pacific hookup for all the fiber coming into Japan from the U.S. So it's really well located, and we're in discussions with multiple buyers, and this is going to be a very attractive, powerful asset that will contribute to solving Japan's data center shortage problem. As indicated earlier, we're also making a hard cut over to semiconductors. I mean, there's some geopolitical reasons for the build out, of course, of semiconductor technology across the world. Japan has significant capabilities in this space. We intend to add to them. We're partnering with Tech Extension, Tex. We're going to use Ishikawa Fab for that. They've got a world-leading technology. It's very powerful, and we're excited about it. I mean, we've got multiple pages to talk about it, so I'll jump forward. We made an equity investment in them. They're doing technology transfer to us. We're bringing up the technology for the first time in Japan. And very specifically, their technology, and they have very strong IP about this, on this, is they come out of Science Tokyo, which is kind of a rebrand of the university, which is Tokyo Tech, which is the MIT of Japan. They have enormous capabilities in, and it's both a integrated development lab and an industrial consortium called the WOW Consortium. So this is not academic. This is very real world. They have tech which is called BB Cube, and it allows you to do vertical stacking in a super efficient way, ultra thin, as you can see on the page. It literally decreases power consumption relative to conventional semiconductor packaging technology to 1/1000th. So this problem of everything melting, the problem of massive demands for power is directly solved through this technology. They've been working on it for a long time. It's ready to be brought into the world, into mass production. We expect to bring it up this year and be in full mass production next year. As I say, there's nothing more exciting than this. This is absolutely transformational for us and for the world, and that's the point. This solves an extraordinary, serious need in the global semiconductor industry, and we're going to go big at it. We're also partnering with Panel Semi. This is Taiwan-based. They're also an extraordinary set of capabilities, particularly in ceramics, and also addressing kind of the heat problems and the problems of current organic substrates that are neither flat enough in order to deal as we get more as we get to finer bandwidths, line widths, and also don't have the heat characteristics that you need. And so we're very, very pleased to work with them. They have a capability that's not only in semiconductor packaging, but also sensors, so it builds out that capability. And again, we've made an investment in them, and we're working forward with them in joint development and commercialization, which will happen very, very rapidly. And this is at the Ishikawa fab. We bring those together. So the reality is that the text technology and the panel semi technology is additive. And so this is, makes us even more powerful in the space in terms of our ability to deliver problem-solving solutions for customers. And the customers are semiconductor makers who need to, again, to have substrates and packaging that deal with the heat requirements, the heat tolerance requirements, and the density requirements of modern AI semiconductors. And both these sets of technologies are deeply relevant to that, and will solve those problems. We're also going in the United States with OLEDWorks, who's an extraordinary company with a global leader in multi-stack OLED technology. We also have significant capabilities in OLED. And so doing something that is important in this space, diversifying out the global set of capabilities in displays. There is no major display activity outside of Asia. And so having a US-based fab to serve customers in the United States in a high-performance way to contribute to 21st industrial competitiveness and national security is something that's really important. We're well along the way in this set of conversations and expect to do this pretty rapidly. And again, this is not only about putting up a brand new fab. It's about building an ecosystem to support it. We have begun conversations with customers, with suppliers. Again, this is being led by OLEDWorks. They are on the ground and have a set of capabilities that are extremely relevant and important. We have a set of technology capabilities to serve them as one of the world's leading advanced display suppliers. So we're grateful to them for the opportunity to work with them. But you're effectively building not just a single manufacturing fab, but a hub that is a source of innovation that will develop human talent, and we'll have an advanced display R&D center that I think will be very, very powerful on a going forward basis. And again, the focus here is not going to be mass market displays, as I said earlier. We think the economics will be very, very compelling for defense, automotive, and medical customers. As I said earlier, ELIP becomes fabless. We are grateful to work with our foundry partners on this. We were going to increase our ELIP capacity. We're going to speed time to market. Our foundry partners have highly competitive cost structures, so this will lower the cost of delivery of ELIP. It's going to build out an ecosystem, which is also going to create economies of scale to lower the cost of delivery. We obviously are going to be fabless on this, and we're not going to have CapEx on it. I think this is a very powerful solution for a technology set. Just to remind you, this is next generation OLED with much better brightness, much better longevity of the displays. The world is going to OLED. It's better technology. It's too expensive. The lifetime is poor. We solve that with ELIP, and we'll solve it together with our foundry partners. So again, our production to configuration in the display space becomes the multi-fab, which is highly competitive, highly cost competitive, and got extraordinary technical capabilities, and we'll also produce it with our foundry partners. We're focused here on ELIP. We mentioned ELIP here. We also have extraordinarily advanced FMM OLED, fine metal mask OLED capabilities. We're working about potentially rolling that also in a fabless way. We do think the future is ELIP over time, but we have a technology set that's relevant to FMM also, and that could be part of this. So that's where we are. We've got the building blocks in place for Beyond Display. It offers a path finally where we've kind of, it's been a really hard push down the cost structure of the firm and a focusing on where we're going to be able to deliver customer value in a powerful way and a sustainable way, and we're ready for it. So we end production At Mobara, we turn it into an AI data center. We get a ton of money, which is great. Solves our financial issues. We become, Ishikawa becomes multi-fab, which is competitive. It does G4.5, G6 displays, including micro displays, semiconductors and sensors. We've got the alliance with Tex to do next-gen 3D semiconductor integration. We've got the Panel Semi Alliance for both advanced semiconductor packaging and sensors. We'll continue to work on sensors. All it works in the U.S. and building out the advanced U.S. fab, and it becomes fabless. That's what we got. Thank you very much. Very much appreciate your time. And I'll take any questions if there are any. Generally there aren't. I'm doing this in the middle of the night. It turns out that since we do watch, to see who watches this is generally people in the United States of America who are not awake at the current point in time. So anyway, but if anyone is around and has any questions, I'm happy to take them.
It appears we have no questions today. We appreciate your time and attention during this briefing. Thank you very much for joining us today, and we look forward to our next meeting. Thank you.
Thank you, everybody. We run forward.